When you think about generative AI, this beautiful image was generated with HAL9 and Flux. I want us to answer the question: where are we in the cycle? Meaning, what things are we missing, and where are we, and how far are we? So, to answer that question, we really need to look at the past and figure out how did the previous iteration of AI look like, and what is it different, and where are we there? Now, my point of view is that we're really in the third iteration of generative AI, of AI. We're in AI 3.0, and we already went over AI 1.0 and AI 2.0. In this video, I'm going to cover the cycle that we went through with AI 2.0 to help us understand where are we in AI 3.0, but I'm not really going to be able to cover what is artificial intelligence 1.0. Just very briefly, artificial 1.0 really have a book here actually from Peter Norvig. This is called Artificial Intelligence: A Modern Approach, and it's really one of the seminal works or books about artificial intelligence 1.0. It covers a lot of the topics like how do you teach a computer to play tic-tac-toe and win, or how do you teach a computer to play chess, where the possibilities are almost endless, and you have to search and do planning to tackle those problems. Today, artificial intelligence 1.0, the way that is described in this book, is not really even considered artificial intelligence. So I'm going to put this back. Really is something that gets taught as a way of learning algorithms and data structures and planning. So we're going to focus on artificial intelligence 2.0 to help us understand 3.0, which is all about generating images, using text and the like for in products like ChatGPT and technologies like GPT and the transformer and the like. So yeah, we're not going to cover AI 3.0, but we want to understand how the previous iteration worked, because that will inform us on what to expect and where we're at in the current cycle. Right, so let me start by saying that I'm going to borrow some information from a book that I wrote on big data. So that's where we're going to start from in our journey of artificial intelligence 2.0. And the particular content that I want to borrow from this book is a chart that describes the world information in terms of being physical and being digital. This really is the chart that gives rise to big data and enabled computers to solve problems that were not possible before. So, before this happened, computers were good at solving problems with small data sets. But as we saw the information that we create became more digital, computers were able to find as an opportunity, be able to solve these types of problems that contain more data. And really the pivotal year, I would argue, was around 2003, is when the amount of data that we create as a civilization became predominantly digital. So before the year 2003, most of the information was being created with books, photographs, newspaper, magazines, contracts, letters, and the like. That was the type of information that the world was creating. And unfortunately, that's kind of like really hard to use unless you have robots, right? You can't really use that information for computer processing unless you digitize it. And it's even more relevant than that. On year 2003, most of the information that humanity started creating became digital, meaning, we have already the internet and web pages, and, we were recording videos in digital format and digital photographs and the like. We saw this explosion of digital information, and it became interesting for, researchers and, computer scientists and the like to tackle the problem of using large data sets, either large numerical data sets and the like, to process that information. Now, the challenge is that we didn't really have the tools to solve a lot of these problems. Like, for instance, when you think of, if you have a lot of photographs and you want to ask a computer, it's like, hey, show me the photographs that have cats in them. That was not a solved problem. So what academia did was creating a dataset called ImageNet that basically contains a lot of images that you can make use of, right? So basically, a lot of researchers got together from Stanford and created a data set to help us, and not help us, but like help other researchers try to solve the problem of dealing with large image data sets. Basically, what they did is they labeled each image, like, hey, this is a car, this is a dog, et cetera, et cetera. And, with that in mind, then, researchers can, were able to get to work and try to improve this particular and solve this particular problem. Now, researchers well known like Jeff Hinton, who won the Nobel Prize in 2024 for his work on deep learning, was one of the creators of the technology that allows us now to classify images. But back in that day, in 2014, it was still very much an open-ended problem. There's actually a comic from XKCD back from 2014 where, the joke goes as follows, right? Like if you were to ask a developer in 2014 to build an iOS app for the iPhone that can detect when you're inside a national park, well, that's a pretty easy problem. You just need to check the GPS coordinates, cross-correlated to, with a database of national parks, figure out if you're inside the national park, and done. You're with that. You're done with the work item. But if you were to ask that same developer, is like, hey, when I take a picture, I want to know if that's a bird. That was pretty much not a problem that was not solved, especially for the developer community. So yeah, back in the day, the joke was like, yeah, that problem is going to take me 5 years and a team of researchers. It was not easy at all. At that time, I was working on Microsoft Research, exactly around that time, and this was a problem that was solved in Microsoft Research to some degree. I actually did a demo. Let me just show you that. And I'm going to forward a little bit more, where Johnson presented the application that I developed using a lot of the research that was created by the researchers at Microsoft Research. It's not that I come up with the solution, but like I built the application that created a use case for this technology once researchers found a way of recognizing dogs, breeds of dogs on ImageNet, and in general many types of objects that are classified in ImageNet, with some of the research that Jeff Hinton and others did in other seminal work like AlexNet and the like. Yeah, so as you can see here, back in 2014, like it was like an amazing demo to figure out that we can actually, classify if an image it's a dog and what type of dog is that. That was like super future focused and interesting, but it was still like a research organization, like academic, a demo, right? Like it was, this does not have a lot of application in the industry. It's like, why would you want to recognize the type of breed of a dog? I mean, yeah, potentially, I don't know if you're, dog breeding, specialist or something. I don't know. I mean, honestly, I don't even know why would you want to do this, like in the real world. But that was like a really cool demo that we did back in the day. It was a demo and it looks promising. It feels like it should have a lot of applications on industry, but it's not clear to figure out like exactly how is this applied. So the next really improvement that had to happen to move us forward was really came from Google with very clever engineers like Jeff Dean, which has contributions to MapReduce and the like on big data processing, and then later on creating a tool called TensorFlow within Google. That really what it does, it's not really doing something different. Like everything that TensorFlow is doing was already done in academia and in research organizations. But really what TensorFlow does is helping us streamline the process of generating these neural networks, differentiating them, training them, selecting their optimization functions, and basically running everything smoothly to the point where you don't need like 5 years and a team of researchers to solve a problem, a computer vision problem. But you could do that literally, like in a few days, right? After you finish learning TensorFlow and the like. Maybe the ramp up is still longer. It's starting to look similar to where we're at today with generative AI, where we'll talk about that in a second. But it's kind of like we need these engineering milestones that simplify and lower the cost of these projects for this to be feasible in the real world. Like applied solutions in the industry and the like. Just to kind of like wrap up on this is how TensorFlow looks like. TensorFlow is really a Python library, so it looks like code. But this utility is called TensorBoard, and it depicts kind of like how TensorFlow works underneath the covers. Like you write some code for a neural network, and then it does all the magic to figure out how to differentiate that, which is like the way of optimizing that neural network. And like you can see the training, like stages, and it does all that working magically in GPUs and CPUs. So like you don't need to worry about writing low-level code. So it's really not new research necessarily, but it's more of new engineering processes that need to be generated, and tooling and libraries that can help us, be able to deliver these projects in a realistic timeline. And if you look at where TensorFlow is today, we can look at their use cases, and it has evolved a lot, right? From, hey, maybe we should use computer vision to recognize dogs, which I don't know what's the application of that, to, hey, maybe we should use it for, security systems. Like I want to know if someone breaks into my store or if someone is stealing something. That is like a real industry use case, but it takes some time to move from academia, solving the problem, building the engineering tools and frameworks and platforms to make those problems, those projects cost effective, and then finally developing understanding on the industry of where to apply this technology. So if you look at the TensorFlow page, there's a lot of examples. Airbnb improves the guest experience by using TensorFlow to classify images and detect objects at scale. So, when you upload something at Airbnb, apparently they use image classification to know if you have one bed, two bathrooms, like nice kitchen, like a toaster, right? And the like. And Airbus is using it for satellite imaging and the like, and so on and so on. There's so many use cases that you can see here that basically tells you that the technology is mature. So let's just go back, or let's move forward, I guess, to AI 3.0. Where are we today? Well, the problem that got stated in the GLUE benchmark, which is a reading comprehension benchmark, is similar to the ImageNet challenge, where a bunch of researchers got together and put together a well-defined problem of what type of things we need to solve. So someone, created the GLUE dataset and, proposed it as a problem to the research community to help answer reading comprehension questions. It would be something similar as a middle schooler reading a couple paragraphs or a couple pages and asking a reading comprehension question like, who is the protagonist, right? Like who was the who's how many cities did the person travel to and the like, right? Anyway, so those types of problems got addressed with research from Google called the transformer, that got inspired from doing work in Google Translate and the like, translating languages. And that's really what gave rise to ChatGPT. And we probably need a few other videos to explain this in depth. Maybe I'll cover them. But what is important on this video is understanding where are we in the cycle. The problem was stated properly. The researchers were able to solve it. And now we have applications like ChatGPT, right? Where in this case, I ask, hey, how can I actually, like in this case, it's just a simple example, like, hey, write a poem about AI. And it's like, hey, the heart of the code, blah, 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 blah. And this is an application that you're familiar with. It's using ChatGPT for reading comprehension or for generating text and the like. But it's also not true yet that we have all the platforms, some of that we're working on in HAL9 to streamline the integration of these types of technology in the industry, right, in your business and the like. So basically, we are still, from my point of view, we're in the cycle where we solved a new problem space in AI, which is reading comprehension, image generation, and the like. We have a few tools that are generic. It's like, hey, what can you do with ChatGPT? anything you want. And we're starting to understand how do they apply to actual business industry problems, right? You know, some companies are applying ChatGPT like LLMs and the like for customer support to reduce the workload that their customer team has. That's one use case. Some other people are using it like us in HAL9 for generating images and content, right? Like the one that I show at the beginning of this, of this particular video, right? Like we use it a lot for our marketing materials and the like. We love to use HAL9 to generate those images. But what I want to say is that it's still not clear what are the high value implementation projects. And we're also missing to do a lot of the work to streamline the projects from an AI, machine learning, and engineering point of view, or to create projects that are easily accessible to businesses, that they can be implemented in low time and low risk. That's a lot of the work that we do in HAL9. We're not ChatGPT, but we're the platform that allows you to take generative AI like ChatGPT and Stable Diffusion, Midjourney, Flux, like these images, like this image shows, and apply it into your business. That's what we do. We have a lot of templates and the like, but that's for another video. I'm gonna close here and mention that I'm super excited for this new iteration of generative AI. Call it AI 3.0. And I think it's gonna show that there's a lot of potential, and I'm super excited to see what you create with generative AI, and definitely write in the comments what are areas of application that you could see generative AI making a big impact on your business, in your team, in your professional career, and the like. Thank you.